Hello guys, today I'm going to show you how to build circuits and to simulate them without having actual the physical electric and electronic components. We're going to use a software known as Proteus 8 Professional and Arduino IDE. Proteus 8 Professional is a platform whereby you can build electronic circuits and you can build all types of electronic circuits and including PCB, and you can be able to simulate them before you actually make the real life connection. Arduino IDE is a platform whereby you build your code for Arduino based hardware, and for it's a platform where you like basically write your code and you can rectify your code, you can compile and you upload to the your board. Now without further ado, let's dive into Proteus 8 Professional. I'm using Proteus 8 Professional version 8.16 SP3, as you can see here. Now we're going to start a new project. You can name it Arduino Project 1. Project 1. Next. Now after that, it brings you to this page. This page is where now you can build your circuit. It has so many tools. I'm not conversant with all of them, but I'm conversant with most of them. So with that, I can be able to build a circuit, simulate, and convert it to PCB, etc. But for this case, we're going to focus on one thing. We're going to do the basic thing that you can do. Build a circuit, load a program, simulate. We're going to start with the number one, building a circuit. So our circuit will consist of two major components. We'll have the Arduino and LED. And for that, let's find Arduino. Depending on the libraries that you have imported in your Proteus, remember when you download Proteus doesn't come with all these libraries. You have to import them yourself. So my libraries I use from different people, and I'm using Simulino Arduino boards. And similarly, we're going to use Arduino board known as Arduino Uno. And here it is. So to press the Arduino Uno, you'll have to click once and the board comes here. And if I want, I can be able to move it around. And if I want to press it here, I have to click another time. And that is it. Bring an LED. LED. We have different type of LEDs as we are shown here, but we need the active LED. With time, you'll know the difference between these other LEDs and the active. The active LED actually grows on the screen and shows you how it's doing. You can see it light up upon getting a signal. So we double tap again. Now we want to rotate this. We let click. Return to clockwise. Done. Build our circuit. We are going to use our pin 13. I'm going to connect Arduino to pin 13. Our LED to pin 13. The positive terminal of the LED goes to pin 13. The negative terminal goes to the ground. So here we have so many tools. We are going to use this terminals mode to be able to get the tool that we want. We want a ground pin. So you can place it here and we connect our negative terminal to the ground pin. And with that you're done. You can see the project. So if it's not visible, you can zoom in, and To move your Arduino around, there's this tool here. You can use it to maneuver so that you can see where it's best. When you're satisfied, you click once, then you exit, and there you can see the full Arduino is there. We save, then we go to Arduino Uno and build our code. As it is initiating, Arduino, if you download the latest Arduino, you don't need to have to input library for this case. You just use the available libraries. But as we progress, you'll see the need of other programs etc. So you're going to first, since this is your first code, I'm going to introduce you to maybe this platform. This is the Arduino IDE. This is where you write your code. I'm not going to give basics of writing a code. With that, you can do later. I'm going to explain to you the tools available and how you use them. This is for using to compile. When you highlight it, it says verify. When you compile, if there are any errors, it will tell you. This is for uploading. For uploading, it has to verify and upload. So if you have a board physically and you want to put a code, you don't need to verify then upload. You can upload. If it has a problem, it won't upload. It will highlight where the error is. We have this for starting a new project. This for opening all your old projects, and this is for saving your project. Up here we have other tools. We have file gives you, this button gives you accessibility to all this. You can start a new project, open an old project, open, show you your recent project, take you to your sketchbook and see all the projects that you have ever written, and examples. These are projects that have been built by Arduino to assist people in doing programming, as well as other third-party libraries. You also see their examples on this page. The rest you don't need to know for now, but you're going to dive into examples, and we go to basics, blink, click. We have blink here. So the code for blink looks like this. Something that you need to know is you have to define to which pin your LED is being connected to. So actually our code begins here. Let me delete this part. This is our code. We have the void setup. This is where you identify the pins that you're going to use. Pin mode, you're defining the pin to be an output. LED built-in pin to be an output. Kindly note here that this pin on Arduino Uno is usually pin 13. Arduino LED built-in is pin 13. So we go to the loop function. This only runs once. Once the Arduino has initiated, you've powered it on, it only runs once. But this is the part of the code that runs over and over again. So in this part of the code, we have digital write LED pin, LED built-in high. This turns on the LED on for 1 second, delay 1000 milliseconds, so that is equivalent to 1 second. After that, it will initiate the second command, which is digital light LED built-in low. Turn the LED off for 1000 millisecond, which is equals to 1 second. And after all this has been exhausted, it goes back to the beginning, and it continues running over and over again until the gadget is interrupted or it's shut down, or you upload another code which will delete this code. Now with that said and done, We're just going to copy Control A, Control C, then we start a new project. And here we come Control A, then we Control V, and we have our code here. We're not going to manipulate our code in any way. We're going to save it as just as it is, and we're going to name it Project 1. Being our Project 1. Now, since this is the same code that I was built by Arduino IDE, so we are not going to do much. Now, that being said and done, we're going now to do the necessary things. First, we verify if the code is okay or we have any errors. Yeah, it's complete. It has finished compiling. My computer is quite slow. I don't have enough RAM, and I'm running some heavy software on the background. The other thing is we're going to export binaries. After compiling, we can export binaries. It will go under the same process of like compiling, but it will export now the binaries. The reason why we're doing this is because Proteus cannot be able to interpret the Arduino code as it is, and during like normally when you're programming your Arduino Uno, the compiler, when you are uploading these tools that actually interpret the code into hex, and that is what now the chip is able to understand. Now with this, since we are putting it to another software, we have to translate it into hexadecimals, and that is what we've done. Now we are good to go. So we go back to Proteus, our initial project that we built, and now to load our program, you come to this chip and click twice, and brings you to this window. You can rename this, or this you can rename them to what you intend. But now we want our main reason for coming here is to load a program. So here it comes back to our former program that I was working on, but I don't want that. I want to give it another one. So I come to Arduino, where I've saved all my programs, and you can see them here. So the program I'm looking for is Project 1. Here it is. You see, no items matching. So what I need to do is to make sure I've exported my binaries. So let me go back here, Project 1. Export compiled binaries again. Let's check if we have. Okay, I'll look into that program, but meanwhile, we'll work with the program that I was working with before. This one I had exported to binaries, and when you select hex, you can choose either of the two, one with bootloader and one without. Say open, and once it's loaded, you say OK. Once you're done, you should come and click outside the component here for it to go back to normal, and you can save, Control S, so that you can be able now to simulate. As I told you earlier in the program, it turns on for 1 second and it turns off for 1 second. And that is our project for today. See you next time.